In this video, we're going to talk about rational expressions, which are important kinds of algebraic expressions that arise very frequently in mathematics. This is an example of a rational expression, and these kinds of expressions arise whenever you take one polynomial and divide it by another. So notice how this expression is equal to one thing divided by another. In other words, it is indeed a ratio, hence the term rational expression. And indeed, both the numerator and denominator of this expression are each a polynomial. Which leads us to the following general definition. We say that a rational expression is simply a ratio of two polynomial expressions, or in other words, a fraction where both the numerator and the denominator are a polynomial. Notice, for instance, that by definition, any polynomial is technically a rational expression. Indeed, the polynomial x squared minus 1 is just equal to itself divided by the polynomial 1. So technically, it counts as a rational expression. A slightly more interesting example is the rational expression 1 over x, or x over x. Or something much more complicated like this. But all of these examples are simply arrived at by taking one polynomial and dividing it by another. So they all count as rational expressions. Now, there are many things to say about rational expressions, but for the time being, we're going to be concerned with just learning how to manipulate them. That is, learning how to do things like multiply or divide or add or subtract rational expressions. Let's begin by considering a concrete example and thinking about what it should mean to multiply two rational expressions. In this case, the expression x over 1 minus x and the expression x squared over 1 plus x. And really, we just need to borrow from our existing knowledge of how to manipulate fractions here. To multiply two fractions, you just multiply the numerators and the denominators by one another, respectively. And that's exactly how we are going to approach multiplying these two rational expressions. So I'm going to begin here by rewriting this as x times x squared, right? We're going to multiply the numerators together, and then dividing that by 1 minus x times 1 plus x, multiplying the denominators together. This, in turn, simplifies to x cubed in the numerator. Right? I'm just going to add those exponents together. And then it's also good, technically not necessary, but a good idea to FOIL out the denominator. And this is going to give us, let's have a look, 1 plus x minus x squared, which simplifies further to x cubed over 1 minus x squared. And that would be the product of our two rational expressions. Let's take a look at what it means to divide two rational expressions next. So this next example is asking us to compute 1 minus x squared over 3x divided by 1 plus x over 6x cubed. The way to proceed here is by once again borrowing from our knowledge of how fractions work. We know that to divide fractions, what we want to do is multiply by the reciprocal, and it will be no different here. So the first thing I'm going to do is rewrite this as a product, and it will be the product 1 minus x squared over 3x times 6x cubed over 1 plus x. So notice that in turning this division problem into a multiplication problem, I really have just multiplied by the reciprocal of 1 plus x over 6x cubed. And I can now proceed just by multiplying the numerators and denominators together. So this is going to give us 6x cubed times 1 minus x squared divided by 3x times 1 plus x. But before simply calling it a day, notice that there's some simplification that we can undertake here. Indeed, the 3 and the x in the denominator will divide into the 6 and the x cubed terms in the numerator. So this allows us to rewrite our expression as 2x squared times 1 minus x squared all over 1 plus x. And careful, we're not done yet, because notice how the factor of 1 minus x squared in the numerator, being a difference of two squares, can be written as 1 minus x times 1 plus x, so that, in fact, the denominator will divide into that as well. This, in turn, allows us to rewrite our expression as simply 2x squared times 1 minus x. And if we care to, we could go ahead and distribute the 2x squared here, but leaving our answer in this form is already sufficient. Finally, let's think about how we would go about adding or subtracting two rational expressions. So let's think about how to add 4 over x minus 3 and x over x plus 2. And we need to be a little careful here because, just as with numerical fractions, we are not allowed to simply add the numerators and denominators to one another. Indeed, before performing any kind of addition, we're going to need to find a common denominator of our two rational expressions, since their denominators are not already equal to one another. And notice that you can always find a common denominator by simply multiplying the two denominators of each term together. So for us, a common denominator would simply be x minus 3 times x plus 2. Once we realize that, we can proceed in the following way. We're going to take the first term in our sum, that's 4 over x minus 3, and multiply it by x plus 2 over x plus 2. That's going to give that term a denominator of x minus 3 times x plus 2 while keeping its value unchanged. That's exactly why we multiply by x plus 2 over x plus 2, which is just equal to 1. And then we're going to do the same type of thing with our second term. We're going to take x over x plus 2 and multiply it by x minus 3 over x minus 3, so that it too will have the correct common denominator. Now the first term in our new sum can be written as 4 times x plus 2, or 4x plus 8, all over the common denominator x minus 3 times x plus 2. And the second term in our sum will be x times x minus 3, that's x squared minus 3x, all over the common denominator of x minus 3 times x plus 2. Only now that our two rational expressions have the same denominator may we add them together, and we do so in the usual way, that is to say, just by adding the numerators together. So the sum of the two numerators will be x squared plus 4x minus 3x, so that's just plus x, and then finally plus the constant 8. And this will have to get divided by the denominator x minus 3 times x plus 2. And once again, if we care to, we could go ahead and FOIL out that denominator, but this is an acceptable way to present the answer. And here are just a few final thoughts to sort of sum up what we've done. Remember that whenever you're manipulating rational expressions, you should basically apply the rules of fractions that you already know. In particular, when you're adding or subtracting rational expressions, make sure that you find a common denominator before proceeding. After you've arrived at an answer, be sure to simplify your rational expression by looking for factors that are common to both the numerator and denominator. And one final remark is that although we've been focusing on ratios of two polynomials, you'll often encounter more general kinds of expressions that are also expressed as a ratio. For example, an expression involving two different variables, x and y, or an expression that involves a square root term or some kind of radical notation. Although these are strictly speaking not rational expressions according to our definition, they can also be manipulated using very similar rules.